This video covers Module 6, Part 2, which is about adding and subtracting rational expressions. This is very similar to how we add fractions, which are an example of a rational expression, but this time there's going to be way more variables involved. So please make sure you are following along with your guided notes. So the first thing we need to do when adding fractions is we need to find the LCD. LCD stands for lowest common divisor. Some people call it lowest common denominator, right? And what we're trying to do is we're trying to find the smallest number that is divisible by our two denominators. So if I have a denominator A and B, the smallest number that is divisible by both of them is the least common, going to be the least common denominator for these. So one example I have is, let's say I had A was 15xy and B was 6xy squared. What I want to do is I want to break that apart into its factors in order to determine the smallest number that's divisible by both. So 15 factors into a 5 and a 3, and then I have one x term and one y term. And I partner those up with all the factors of 6. 6 factors into a 6 and a 2, a 3 and a 2. You can see I have the 3's lined up together in this column. But I've also got a single x and two y's. So I put the x's with the x's and the y's with the y's. And then I collect all the factors that appear. So I have a 5, a 3, an x, two y's, and a 2. And if I multiply all of these together, then we will get the lowest common denominator of 30xy squared. So one way to find these is to break them up into a table. That's the way I like to do it, to keep track of all my factors. Another way is to just kind of look at it and see what the smallest number you can think of that would be divisible by both. That's not the most effective use of our time. Another reason we want to find the lowest common divisor is because if I was to multiply 15 times 6, that would be a pretty big number, right? I'd be multiplying it by an extra factor of 5 that I don't need. So we want to find the smallest one because it's smaller math for us to work with. So for 12, I know that 12 factors into 4 times 3, and 4 factors into a 2 and a 2. So the factors of 12 are 2 and 2 and 3. And 20 factors into 2 times 10, which is 2 times 5. So 20 factors into a 2, which I already have a factor 2 I can pair it with, another 2, and then a 5. So if I collect all of these factors, 2, 2, 3, and 5, and I multiply these together, that's going to give me my least common denominator, which is going to be 2 times 2 times 3 times 5, which is going to give us 60. I do the same thing when there are variables involved. 10 is going to factor into a 2 and a 5, but I also have an A and a B. 5 is prime, so it doesn't factor down, but I've got 2 A's. So I could organize a table if I wanted to figure out what my least common denominator is. So for 10AB, I have a 2, a 5, an A, and a B. And for 5A squared, I have a 5, an A, and another A. So the least common denominator would be 2 times 5 times A times B times A, which would be 10A squared B. Let's practice finding the LCD of some more examples. So here I have 3x over y squared minus 2y minus 8, and 4y over y squared plus 3y plus 2. And I need to find the factors of these denominators, which means I need to factor them. Y squared minus 2y minus 8, I think, what are the factors of negative 8 that add up to negative 2? Well, that's negative 4 and positive 2. y squared plus 3y plus 2, I think, okay, what are the factors of positive 2 that add up to 3? Well, that's going to be y plus 1 times y plus 2. And so I need to collect all the factors that they don't have in common. So if I'm trying to figure out the least common denominator of this, I could make a table if I wanted. It's going to be a little clunky, but we've already started, so we might as well. So I've got x minus 4 and y. We were using y's. Y minus 4 and y plus 2 are my factors. And then for my second trinomial, I had y plus 2 as a factor and y plus 1 as a factor. So my LCD, which we want to leave in factored form, so we can see if we can simplify when we're adding or subtracting these, we're going to leave in factored form, is going to be y minus 4 times y plus 2 times y plus 1. We just need every single factor that we see represented. So for B, I've got 8z minus 24 as my denominator and 5z times z minus 3 is my denominator. Well, I can factor my first denominator, so I've got 8 times z minus 3. And my second denominator is 5z times z minus 3. That z minus 3, that's what they have in common. So I would need to find the LCD. It's going to be 8 times z minus 3 times 5z. And I could go ahead and write this if I wanted to as 40z times z minus 3, or I could leave it fully factored. It's up to you. So when we're adding and subtracting rational expressions, if the denominators are the same, we add or subtract the numerators and place the results over the denominators. That's this first example here, right? When we're adding fractions or subtracting fractions with the same denominator, we add the numerators or subtract them and just write them over the same denominator. If the denominators are different, we have to find the least common denominator and write all expressions with the same LCD. So we have to make it so all the fractions have the same denominator. Then we can add or subtract them and place it over the common denominator. And we do that by harnessing the power of 1. So for 5 over 2p squared plus 3 over 8p, I see that the LCD is going to be 8p squared. So I have to multiply this first fraction by p over p, and the second fraction by 4 over 4, harnessing the power of 1. So I'd have 20 over 8p squared plus 3p over 8p squared. That gives me 20 plus 3p over 8p squared. So let's practice adding some fractions first with the same denominators and then with different denominators, and we need to make sure that we are simplifying, if we can, as we saw in section 6.1, as we go along. So we already did this first example, but I can do it again. I have 3y plus x over 5. For my second example, I have 7 minus 11 over 2r squared. 7 minus 11, that gives me a negative 4 over 2r squared. And then I see that I can simplify out a factor of 2. So I have negative 2 over r squared. For my second example, I'd have 7x minus x minus 2. We have to distribute this negative and write it over the same denominator. That would give me 7x minus x plus 2 over 3x plus 1. That gives me 6x plus 2 over 3x plus 1. I could factor my numerator to have 2 times 3x plus 1 over 3x plus 1. That gives me a final answer of 2. So we need to make sure we factor and simplify if we can. Here I have m plus p over m squared minus p squared. Since my denominators are the same, I can go ahead and add these. And then I want to factor my denominator, which in this case is a difference of squares. So it's going to factor into m minus p times m plus p. And we see our m plus p's cancel, so I'm left with 1 over m minus p. Next, I have 4 plus x. I'm going to rewrite this as x plus 4. And both of these are over x squared plus 2x minus 8. I can then factor my denominator, x plus 4 over x plus 4 times x minus 2. Because what are the factors of negative 8 that add up to 2? Well, that's 4 and negative 2. And since my leading term is 1, I can use this shortcut. Those cancel, and I have 1 over x minus 2. So again, what we need to do when we're adding and subtracting rational expressions is we need to make sure they have the same denominator. So what I do is I would factor all numerators and denominators, simplify the fractions if you can, then multiply as needed to obtain like denominators with the least common denominator, and then again simplify. You might have to factor in order to do this. So for example, if I have 7 over 15 and 5 over 12, 15 factors into a 3 and a 5. 12 factors into a 3 and a 2 and a 2. So I say, okay, my greatest common factor is going to be 3 times 5 times 2 times 2, which is 60. So 4 over 4, because 4 times 15 would give me 60, so I have 28 sixtieths, plus 5 over 5. 5 times 5 is 25. 5 times 12 is 60. That gives me 53 sixtieths, and I can't simplify that any further, but that's how we're going to go about adding fractions. So if I have 6 over x minus 5 over x minus 3, my least common denominator is going to be those two multiplied together because both of these are prime factors. So my LCD is going to be x times x minus 3. And I know you're really tempted to distribute, but do not. Leave it in factored form. So on the left, I'm going to multiply by x minus 3 over x minus 3. And on the right, I'm going to multiply by x over x. So I have 6 times x minus 3 over x times x minus 3 minus 5x times x minus 3. So I'll distribute in my numerator. I've got 6x minus 18 minus 5 over minus 5x over x times x minus 3. Then we can combine like terms. I've got x minus 18 over x times x minus 3, and I can't factor my numerator any further. I can't simplify my denominator anymore, so this is fully completed. You can leave these in factored form, or you could go ahead and distribute that x if you so wish. I would just stop here. You don't need to do the extra step of redistributing or refoiling, whatever may be the case. So if I have 1 over q minus 1 minus 1 over q plus 1, my LCD here is just going to be q plus 1 times q minus 1. So on the left, I'm going to multiply by q plus 1 over q plus 1. On the right, I'm going to multiply by q minus 1 over q minus 1. That gives me q plus 1 over q plus 1, q minus 1, times q minus, not times, what am I doing? Subtracting. Minus q minus 1 over q plus 1, q minus 1. Now my denominator is the same. I've got q plus 1, and I've got to distribute this negative, minus q plus 1 over q plus 1, q minus 1. So I have 2, because my q's cancel out, over q plus 1 times q minus 1, which if I wanted to, I could FOIL out to get q squared minus 1. For my second example, I have y over y squared minus 25. That's a different of cubes. So let's go ahead and write that out. So I have y over y minus 5 times y plus 5 plus 8 over y minus 5. So my LCD is going to be y plus 5 times y minus 5, or I could have written the y minus 5 first. The order doesn't matter. On the right, I need to multiply by y plus 5 over y plus 5. So I have y over y minus 5 times y plus 5 plus 8y plus 40, and that's all over the same denominator. So now I have 9y plus 40 over y minus 5y plus 5. And I can't simplify my numerator. There's nothing to factor out. I could refoil the denominator if I so wished, but I would just recommend leaving it in factored form. For this example, we've got not one, not two, but three fractions. So I have x minus 2 plus x minus 6 over x squared minus 2x. And you could see if you factored this that you would have x over x minus 2. So my LCD, what I'm trying to get every denominator to look like, is going to be x times x minus 2. Because I have an x minus 2 here, which I just need to multiply by x, and I have an x here that I just need to multiply by x minus 2. So I know what my new denominator is going to be. My new denominator is going to be x times x minus 2. I'm going to have 3x plus 5x minus 10 minus 6. That gives me 8x minus 16 over x times x minus 2. I could factor out an 8. Those x minus 2's cancel, and I'm left with 8 over x. For our last example, I have m plus 4 minus 2m minus 3. M plus 4 over m squared minus 2m minus 3 minus 2m minus 3 over m squared minus 5m plus 6. The first thing I need to do is factor my denominators so I can figure out what my LCD needs to be. So I think, okay, what are the factors of negative 3 that add up to a negative 2? That's going to be negative 3 and positive 1. Okay, what are the factors of 6 that add up to negative 5? That's going to be negative 2 and negative 3. So I have an LCD where I need one of each of those factors that's present of m minus 3 times m plus 1 times m minus 2. So my first fraction, I'm going to have to multiply by m minus 2 in the numerator and the denominator. And my second fraction, I'm going to have to multiply by m plus 1. So my denominator is going to be m minus 3 times m plus 1 times m minus 2. And again, the order of those three terms doesn't matter. My numerator is going to be m minus 2 times m plus 4 minus 2m minus 3 times m plus 1. And in order to see if I'm going to be able to simplify out anything, I need to FOIL those numerators. I'm going to have m squared plus 4m minus 2m minus 8. And that's going to simplify. That's going to simplify to m squared plus 2m minus 8. Let's put that down here. Never enough room. And then if I FOIL this out, I'm going to get 2m squared plus 2m minus 3m minus 3. So I have 2m squared minus m minus 3. And that's what we're subtracting all over our same denominator. So staying organized is very important. Checking your FOILing is very important. So I've got m squared plus 2m minus 8 minus 2m squared plus m plus 3, because we distribute this negative. And then we combine like terms and really hope something simplifies out in the end, because this was a lot of work if nothing's going to simplify. So I have negative m squared. 2m plus m is 3m. Negative 8 and 5. 3 gives me negative 5. I don't like negative leading coefficient, so I could pull that negative leading coefficient out. But we can kind of see that there are no factors of positive 5 that add up to negative 3. So this is fully factored. Nothing simplifies out, which is kind of a bummer. So that's going to be our final answer all over our major denominator.